Today we're going to take a look at parallel and perpendicular lines and how that applies to slope. So first up, parallel lines are lines that never intersect. So lines that are running absolutely next to each other, and in order for them to do that and never cross over, what they have to have is the same slope. They actually have to have different y-intercepts as well. Remember, if you wanted two lines to kind of go beside each other without crisscrossing, they start in different places and then they run the same path or they run in the same direction. So they have the same slope. So just a quick example might be, let's say I have y equals 1/3 x minus 1. That has a slope of 1/3. And it started at -1. Well, if I wanted it to run parallel, my slope would have to be the same so that they run in the same direction, but I would start in a different place. So maybe I would start at +2. So we'd start in different places, but we're going to run the same direction. We're going to have the exact same slope. When I look at perpendicular lines, my lines do intersect, but they intersect at a perfect 90 degrees. So think about the difference between north and south and east and west, or longitude and latitude. Now, when we think about the slope, that means that my slopes have to be pretty much the exact opposite of what they are. So for instance, let's say I had a slope again of y equals 1/3 x minus 1. Well, if I want that to be perpendicular, what I need to have happen is I need that slope, that 1/3, to be the opposite. First up, it's positive, so now I want it to be negative, and I'm going to flip it. I'm going to reciprocal. So the reciprocal of 1/3 is actually 3, right? Or 3/1. So -3x, and then I could have any y-intercept. It doesn't matter. So we could just do the +2 again. That's fine. What makes the difference is all about the slope. And that's what we're going to talk about today. We're going to talk about slope. Are they the same slope? Or do we have opposite reciprocals? So let's take a look real quick just to make sure we're on the same page of what a negative reciprocal is, or an opposite reciprocal. And that is a fraction. So we're going to take that fraction. If we don't have a fraction, we're going to think about it as a fraction, because all slope, when we're graphing a slope, we need both the rise and the run. So we have a fraction and we're going to flip it, meaning the numerator goes to the denominator goes to the numerator, and then the signs need to switch, meaning if it's positive, it's going to become negative. If it's negative, it's going to become positive. So a couple of examples. If I have the slope 3/4 and I want a negative reciprocal or an opposite reciprocal, I'm going to go, well, negative, because this one's positive, and I'm going to go from 3/4 to 4/3. If I have a slope of 2, again, that is a positive 2 as a fraction. That would be 2/1. Opposite would be negative, and if I flip that, reciprocal would be 1/2. Number 3 here, I have -7/8. Well, opposite of a negative is a positive, and then I'm going to reciprocal or flip, and I have 8/7. My last one here, I have 1 as a fraction. That would just be 1/1, right? So if I flip that, it's still 1/1, which seems a little strange, but my slope is just -1 if I simplify that. So if I have a slope of 1, the reciprocal would be -1. And then we also have to think about our special cases. So I have a slope of 0. Remember, a slope of 0 is a horizontal line. We talked about that using Hoy. If I want it to go the exact opposite, I'm going to need a vux. I'm going to need a straight up and down, which means that my slope would be undefined. So that's one of those special cases. So let's take a look. We're going to try a couple. Determine if the segments of AB or CD are parallel, perpendicular, or neither. Meaning, I need to find their slopes and determine, are they the same or are they opposite reciprocals? That's what I want to know. So I'm going to start with AB here. Remember, we're just using our slope formula. So M equals So AB I'm going to do first. My slope is 6 minus 3 over 2 minus negative 2, so that's like adding. This would then be 3 over 4. So I know what my slope is for AB. So now let's find my slope for CD. Again, M equals my Y2, so 3 minus Y1, which is 0. I'm going to take the x's, so 3 minus negative 1 would be plus 1, and my slope would be 3/4. Well, 3/4, that would mean I would have parallel lines because 3/4 and 3/4 are the same. Let's take a look at number 2. In number 2, I have AB to get started. So for segment AB, my slope would be 4 minus 2 over 5 minus 0. That would simplify to 2 over 5. I would look at CD, my slope here, Y2 minus Y1 would be 3 minus 8 over 3 minus 1. So 3 minus 8 is negative 5. 3 minus 1 is 2. So if you notice, I have 2/5 and negative 5/2. Those are opposite reciprocals, so these would actually be perpendicular. All right, number 3. AB. Gonna look at my slope. I have 6 minus 8, and 2 minus negative 1 would be plus 1. So here my slope would be negative 2 over 3. I'm going to do the same thing for CD. My slope is 3 subtract 2, Y2 minus Y1 over X2 minus X1. So 3 minus a negative is a positive, so plus 1. I would have 1 over 4. Now, those are nowhere near each other. They're not the same. They're not opposite reciprocals. So in this case, I would say it's neither. These are actually two slopes that are just going to meet somewhere on the graph. Okay, let's go ahead and pause, and I want you to try number 4. Come back and double check before we flip the page. All right, so here on number 4, AB has a slope of negative 1/3, where CD has a slope of 3. Now 1/3 and 3 are reciprocals, and the first one was positive, the second one was negative, so we have perpendicular lines. Let's go ahead and flip to number 5. Okay, number 5, AB, we're going to go ahead and find that slope. We have 7 minus negative 2, so plus 2, over 0 minus 0, which is 9 over 0. Now remember, I cannot have a division of 0 in the denominator, so this would be an undefined slope. So let's check out CD. The slope here would be negative 5 minus negative 5, so it'd be negative 5 plus 5. In my denominator, I have 6 minus 3. Simplify, negative 5 plus 5 is 0, and 6 minus 3 is 3. Now 0 divided by 3 I can absolutely do, and my slope here is 0. Now I have an undefined, so I have a vertical line. I have a 0, so I have a horizontal line. Therefore, I have perpendicular lines. All right, try 6, 7, and 8 on your own. All right, number 6 is parallel. We have a negative 1/2 and a negative 1/2. Those are the same slope. Number 7 is also parallel, as both lines are undefined. And then in number 8, we have a perpendicular. AB was negative 1 and CD was positive 1. If it helps you to think about that, you can always set them up as fractions. And you'll see that one is positive, one is negative, and they are absolutely flipped. So up next, we're going to just take a quick look at equations. Equations, I think, are a little bit easier because you don't have to spend as much time looking for the slope of each, so you don't need the slope formula. We'll start with number 9 here. Number 9, we've been given y equals mx plus b and y equals mx plus b. So what I'm going to do is look at both equations and find my slope. Now, again, the slope is the m. So the first equation, y equals 7x plus 2, the slope is 7. The second equation, y equals 7x minus 1. The m, or what's attached to x, is 7, so my slope is 7. Well, if they're both 7, then I have parallel lines. Number 10. I love the fact that they gave it to me in y equals mx plus b. Y equals 4/5 x minus 8. There's my slope. So in the first one, my slope is 4/5. I look at my second equation. Y equals, so I already know that I'm looking at the right format, negative 5/4 x plus 3. The m is attached to x, so m equals negative 5/4. I look at those, I think, oh, they're opposites. One's positive, one's negative, and that fraction's flipped, so they are reciprocals. That makes this perpendicular. When I look at number 11, same thing. Look, I've got a negative 1/3 and a 1/3. So if you think about that, negative 1/3 and 1/3, they're similar, but they are absolutely not the same, and they're not reciprocals. The fractions are not flipped, so I'd say, well, this is neither. Now, number 12 is a little different. In number 12, they gave me equations in standard form. They changed it around a little. So first thing I'm going to need to do is get these into slope-intercept. So I'm going to start with the first equation. Remember, we're solving for y, so we're going to go ahead and move the x over. So now I have 6y equals negative x plus 30. Still solving for y, so I'm going to divide everybody by 6. And I'm going to have an equation of y equals negative 1/6 x plus 5. There's my first slope, negative 1/6. Now I need to work on the other equation. I see that I have 3y equals 18x minus 6. Now I'm going to divide everybody by 3 because the y is by itself. It just has a 3 as a coefficient. And this is going to leave me with y equals, well, 18 divided by 3 is 6. So 6x and then negative 2. So here's my slope, 6. So negative 1/6 and a 6, those are opposite reciprocals. Opposite reciprocals are then perpendicular. Number 15. First, I just want to look and see what they've given me. I notice that the first equation is in standard form. Well, if I want to talk about slope, I've got to change this into slope-intercept. So I'll begin by subtracting my 5x from both sides. Okay, so my new equation would be negative y equals negative 5x plus 4. That's a negative y, so I need to divide everybody by negative 1. And my equation would then be y equals, now negative 5 divided by negative 1 is a positive 5, so 5x, and then negative 4. Okay, what about my second equation? Oh, y equals negative 1/5 x plus 7. That's already y equals mx plus b. There's my slope, negative 1/5. So I'm comparing 5 and negative 1/5. Those are opposite and they're reciprocals. So these are perpendicular. Number 14 and number 15. When I look at 14, I notice that those are both in standard form, so you're going to need to change them into slope-intercept form to compare their slopes. Number 15 is already in slope-intercept form, so you're just going to compare their slopes. And then I want you to try number 16. So try 14, 15, and 16. Remember, I need them in y equals mx plus b in order to compare, and then come back and check. All right, on number 14, when we get those into y equals mx plus b, we find that both slopes are positive 3. And since they're the exact same, I have parallel lines. In number 15, they were already in y equals mx plus b, so I just found the m, or the slope. And for the first equation, my slope was 1. The second equation, my slope was -1. And 1 and -1 are opposite reciprocals, so that is perpendicular. And then in 16, I have y equals 6 and x equals -1. Well, remember y equals 6, that's one of those special equations. That's our HOI, it's a horizontal line. I have a slope of 0. And then when I have x equals -1, because it's just x, that's a VUX, vertical, undefined slope. And because I have a horizontal and a vertical line, I have a perpendicular slope. So again, parallel and perpendicular, it's all about the slope. If they're the exact same, you have parallel lines. If you have opposite reciprocal, you have perpendicular.